Hello everyone. Welcome back to the lecture series of mole concept. This is a chapter from ICSE 10th chemistry. This is the second video of mole concept. In the previous video we have done the numericals from Gay Lussac's law. In today's video we will cover the numericals from Avogadro's law. My name is 𝑦𝑪𝑺𝑬 and you are watching 𝑦𝑪𝑺𝑬 classes. Let's get started. So before doing the sums from Avogadro's law, we need to remember few relationship. What is that few relationship? I'll just tell you. In chemistry, we often hear a word called mole. 1 mole of carbon dioxide, 1 mole of a substance. So what is this mole? In chemistry, mole means some amount of substance, and that amount of substance can be expressed in grams. It can be expressed in volume. It also can be expressed in number of particles. So basically mole is some amount which can be expressed in grams, that is in weight or mass you can say. It is expressed in volume and it is expressed in number of particles. So we need to remember this relationship that 1 mole of a substance that is equal to the molecular weight, or the other name for molecular weight is molar mass of that substance. So as you know that molar mass is always expressed in gram, that means 1 mole can be expressed in gram. That is equal to 22.4 liters at STP. So 1 mole of any substance can be expressed in volume. Liters means it is volume. That is equal to 22.4 liters at STP. And that is equal to 6.023 into 10 raised to power 23 number of particles. Okay. Now, when I write particles, it can be atom, it can be molecules, or it can be ion, depending on the substance we have. Okay. Now, whenever we have to do the sums, we need to find out the relationship. We have to extract the relationship from this 4. How do we extract it? What is given and what is asked. Those two things we will extract from here and we'll do the sums. Right? So let us start with the numericals. You will have a better idea once we do the numericals. So let's start with the numericals. So let's start with the first numerical. See, it is given that find the number of molecules in 73 gram of HCl. Now we need to see what is asked over here. They are asking number of molecules and what is given 73 gram of the substance is HCl. So now you understand from this 4 relationship, number of molecules is related to this Avogadro's number, okay, and 73 gram which is given, that is related to molecular weight of the substance. So we will extract these two things, and since our substance is HCl, we'll write molecular weight of, in place of substance, we are going to write HCl. So, molecular weight of HCl is equal to 6.023 into 10 raised to power 23 number of molecules. Okay, molecular weight is equal to Avogadro's number of molecules. Now, what is the molecular weight of HCl? Chlorine is 35.5 and hydrogen is 1. So, it is 36.5 gram is equal to 6.023 into 10 raised to power 23 number of molecules, right? So what they are asking, 73 gram. So if it is 73 gram, then what is the number of molecules? Suppose it is X. Now we have to cross multiply. So it will be 36.5x is equal to 73.6.023 into 10 raised to power 23. Okay, so x is equal to 73, sorry, here it is a multiplication sign, 73 into 6.023 into 10 raised to power 23 divided by 36.5. So when you calculate this, you get the number of molecules. Now see, this is point, I'll just remove this point, I'll take a 10 down, 365 upon 10, and that 10 will go up in the next step. So it will be 73 into 6.023 into 10 raised to power 24 upon 365. Now 365 goes in 73's table, it is 73 into 5. So we are getting 6.023 divided by 5 into 10 raised to power 24. I have separated this order. I have just taken 6.023 upon 5. Now I'll just divide this part. Okay. So what is it coming? 5, 1, 1, 0, 5, 2, 0, 23, 5, 4, 3, 0, 5, 6. So 10 raised to power 24. So this is the answer. These many molecules are present in 73 gram of HCl. Let us see the second question now. They are asking for weight of 0.5 mole of oxygen. So we need to find out the weight which is related to molecular mass of 0.5 mole which is related to 1 mole, and the substance is oxygen. So we'll now take out this and we'll write 1 mole of oxygen is equal to the molecular weight of oxygen. Okay, so 1 mole of oxygen, 1 mole of oxygen. Now molecular weight of oxygen is 32. So we'll write it here, 32 gram. Therefore 0.5 mole is equal to how much gram? Now we just cross multiply. So x into 1 is x is equal to 32 into 0.5. If you can just multiply this, or you can write down 5.5 can be written as 5 by 10, which is 1 by 2, and this is 16. So we are getting 16 gram. So the number of moles, weight of 0.5 mole of oxygen is 16 gram. Okay. Let's see the next question. This is also done. The next question is, we have to find the number of molecules in 1.8 gram of water. So now number of molecules means it is related to Avogadro number, which we need to find out, and 1.8 gram of water means it is related to molecular weight of water, right? So we will now take these two things and we'll write, and the substance is water, right? So we'll write molecular weight of water is equal to 6.023 into 10 raised to power 23 number of molecules. Now in place of particles we are writing molecules because water is a compound and the smallest particle of any compound is molecules. So in particles, in place of particles we are going to write molecules over here. If this was an element, we would have been written in place of molecules, would have been written atoms, because the smallest part of an element is atom. So this particles word will change as per the substance over here. Okay. So molecular weight of water is 18 gram. 18 gram is equal to 6.023 into 10 raised to power 23. So 1.8 gram is equal to how much? It is x. Cross multiply, get the answer. You can easily see here 18 to 1.8 means we have divided by 10. So here also we can divide by 10. So directly the value of x will be 6.023 into 10 raised to power 22. Just divide it by 10, 10 raised to power 23 will become 10 raised to power 22. If you do not understand that way, then you can multiply, cross multiply and get the answer. This was a very easy calculation. So I did it at once, right? So this way we need to relate the two things from this given relationship. What is given and what is asked. We will take out from this and we will solve the question. Let us see more questions. Let us start with the fourth question. They are saying find the number of moles in 10 gram of CaCO3. So they are asking for the number of moles, and what is given 10 gram of CaCO3, that means number of moles, 1 mole of a substance and 10 gram, that is molecular weight. These two things we have to take out. So we'll write 1 mole of, now the substance is CaCO3 is equal to molecular weight of CaCO3. Now I hope everyone knows how to find out the molecular weight. If not, I am doing it here. CaCO3, the molecular weight of this. Now molecular weight is nothing but the algebraic sum of the atomic weights of all the elements present in the molecule. What did I say? molecular weight is the algebraic sum of the atomic weights of all the elements present in the molecule. So here you can see Ca, that is one element, C, that is another element, carbon, and oxygen, that is third element. And how many oxygen presents? O3 means there are 3 oxygen present. That means we need to take the atomic weight of calcium, which is 40, plus atomic weight of carbon, which is 12, plus 3 into atomic weight of oxygen, which is 16. So we'll write here 3 into 16. So now you calculate 40 plus 12 plus 48 and it will come 100 gram. So molecular weight of calcium carbonate is 100 grams. So now we'll write 1 mole of CaCO3 is equal to 100 gram of CaCO3. So what is the weight of 10 grams? So how many moles? Sorry, number of moles. So 10 gram will come here and we need to find out the number of moles. So now cross multiply. It is 100x is equal to 10 or x is equal to 10 upon 100, that is 0.1. So how many moles are present in 10 gram of CaCO3? It is 0.1 mole. Okay, so that is the fourth sum. Now let us see the fifth sum. The fifth sum is weight of 0.2 mole of hydrogen gas. So what they are asking weight. Weight is related to molecular weight, and what is given 0.2 mole, which is related to 1 mole of a substance, and our substance is hydrogen gas. So we'll take out now this and this. We'll write 1 mole of hydrogen gas is equal to molecular weight of hydrogen gas. Now 1 mole of hydrogen gas. What is the molecular weight of hydrogen gas? It is 2. We take it approximately 2. So that is 2 gram. Therefore 0.2 mole will be is equal to 0.2 into 2. Will be is equal to x basically. Will be x. So now you cross multiply. So x will be 0.2 into 2. That is 0.4 gram. So the weight of 0.2 mole of hydrogen gas is 0.4 gram. I hope now you are understanding how we are doing the sums. We have this relationship, the 4 things which are related to each other. So what is given and what is asked, we are taking out from here and accordingly we are calculating. Let us see the next sum, question number 6. We need to find out the number of molecules in 3.2 gram of sulfur dioxide. So now you understand that number of molecules is related to this Avogadro's number of particles, and 3.2 gram which is given is related to molecular weight. That means in this case we have to take molecular weight and number of particles, these 2 things. And our substance is SO2. So we'll write molecular weight of SO2 is equal to 6.023 into 10 raised to power 23 number of molecules. Now again, particles will be replaced by molecules because now our substance is SO2, which is a compound, and the smallest particle of a compound is molecule. So we have replaced particles with molecules. Now, molecular weight of sulfur dioxide, let us find out what is it. SO2, so here 1 sulfur and 2 oxygen. 1 sulfur is 32, 2 oxygen is 2 into 16, so it is 32 plus 32, which is coming 64 gram. So here we'll write 64 gram of SO2 will be is equal to 6.023 into 10 raised to power 23 number of molecules, right? Therefore, what is given? 3.2 gram. So 3.2 gram is equal to how many molecules? Now we cross multiply this, we get 64x is equal to 3.2 into 6.023 into 10 raised to power 23. Therefore, x is equal to 3.2 into 6.023 into 10 raised to power 23 divided by 64. Now, 32 and 64, we can understand that this goes by 32 stable. So what I'll do is, I will remove this point. If I remove this point, I'll take a 10 down, and that 10 and this 10 raised to power 23 will get cancelled. So I'll show you how we are doing it. 32 upon 10 I have taken to remove the point. 3.2 can be written as 32 by 10. Then we have 6.023 into 10 raised to power 23, and down we have 64. Now this 10 and this 10 raised to power 23 will get cancelled and it will be 10 raised to power 22, and 32 and this will get cancelled, it will be 2. So now I can simply do 6.023 divided by 2 and 10 raised to power 22 will remain as it is. Okay, I'll show you the calculations over here. I'm sorry, there is the space problem is there, so you have to understand a little bit. So we are getting from here, we are getting 6.023 divided by 2 into 10 raised to power 22. Now divided, it is 3, then 0, 1, 2, 5 into 10 raised to power 22 number of molecules. Sorry. So what they have asked, number of molecules in 3.2 gram of sulfur dioxide. So there are 3.0125 into 10 raised to power 22 number of molecules in sulfur dioxide. Okay, so the next question in front of us, that is, which of the following would weigh most? 1 mole of H2O, 1 mole of CO2, 1 mole of NH3 and 1 mole of CO. So we know already that 1 mole of any substance is equal to the molar mass of that substance. Now H2 is also given 1 mole, carbon dioxide is also given 1 mole, NH3 is also given 1 mole and CO is also given 1 mole. That means we need to find out the molecular weights of these substances. So let us see, 1 mole of H2O is equal to molecular weight of H2O, and we know the molecular weight of H2O is 18 gram, but still you can do, there are 2 hydrogens, 2 into atomic weight of hydrogen which is 1 plus atomic weight of oxygen which is 16, so it's coming 2 plus 16, that is 18 gram. Okay, now let us take the next one, that is 1 mole of carbon dioxide. Most of you also know the weight of carbon dioxide, the molecular weight of carbon dioxide, it is 44, but we'll still do it. Molecular weight of carbon dioxide is the atomic weight of carbon which is 12 plus atomic weight of 2 oxygens, that is 2 into 16, so it is 12 plus 32 which is 44 gram. Now let us see the third part, that is 1 mole of NH3. This is also, most of you know, it is 17 gram. So molecular weight of NH3, ammonia, is 17 gram, but let us say this, nitrogen is 14 plus 3 into atomic weight of hydrogen, that's 1. So 14 plus 3, that is 17 gram. And finally we have 1 mole of CO, which will be definitely less than CO2. So let us see, so that's molecular weight of CO, that is 12 plus 16, which is your 22 gram. 6 plus 2 is 8, sorry, 28 gram. Okay, so from here we can see the most, this is the maximum weight. So we will say that which of the following would weigh the most? 1 mole of carbon dioxide will weigh the most. So the next question is, question number 8, which of the following has the maximum number of molecules? And here it is given 4 gram of oxygen, 4 gram of ammonia, 4 gram of carbon dioxide and 4 gram of SO2. That means the gram, it is given in gram and it is asked the number of molecules. That means molecular mass of the substance is equal to Avogadro's number of molecules. These two things we have to take out from the 4 relationships. Okay, so we'll write for the first one, molecular weight of oxygen is 6.022 into 10 raised to power 23 number of molecules. Now, what is the molecular weight of oxygen? It is 32 gram is equal to 6.022 into 10 raised to power 23. Okay, now 4 gram is equal to how much? So we can cross multiply. So that is 32x is equal to 4 into 6.022 into 10 raised to power 23. Therefore, x is equal to 4 into 6.022 into 10 raised to power 23 divided by 32. So this is divided by 8. So it is 6.022 into 10 raised to power 23. Don't calculate it, just let it be like this. Let us see what we get from the other things. B is 4 gram of ammonia. So we'll write molar mass, molecular weight of ammonia is equal to 6.023 into 10 raised to power 23. Now molar mass of ammonia is 17 gram. 17 gram is equal to 6.023 into 10 raised to power 23. Therefore 4 gram is equal to 6.023. 10 raised to power 23 divided by, actually we have to cross multiply. So 17 into x is equal to this into 4 divided by 17. What we will do is we'll not cancel it out, because it is coming same for all of them, so it will be easier to calculate. Let 4 be there, okay? So from here we are getting this, the value of y, suppose we are getting 4 into 6.023 into 10 raised to power 23 divided by 7. Now you can see the numerator here and the numerator here is same. But here it is divided by 32, here it is divided by 17. That means if the denominator is more, then the overall value gets decreased. So if you are asked to compare between these two, then this value is less because the denominator is more. So the overall value will be reduced, okay? So they are asking which of the following has the maximum number of molecules. So definitely this is not. Here this has already more number of molecules. So cut this, let us see the next one, that is C part. Okay, C part. C part is 4 gram of carbon dioxide. So molar mass of carbon dioxide is, molecular weight of carbon dioxide is equal to 6.023 into 10 raised to power 23 number of molecules. Therefore, 44 gram is equal to this many number of molecules. So 4 gram is equal to how many molecules? Let it be A. So A will be is equal to 4 into 6.023 into 10 raised to power 23 divided by 44. Now again you can compare between these two. You can see the numerators are same. Again the denominator is more. So definitely this overall number will be less. Again this is having more number of molecules. So we'll rub this and we'll do the last part, that is D, which is 4 gram of sulfur dioxide. So molecular mass of sulfur dioxide is 64. So 64 gram of sulfur dioxide is equal to Avogadro number of molecules. Therefore 4 gram is equal to, suppose it is B. So B will be is equal to 4 into Avogadro number divided by 64. Now again you can see this is more because here the denominator is 64, the overall value will be less. So among all these 4, this is having the maximum number of molecules. Question number 9 in front of you. Question number 9 says calculate the number of hydrogen atoms in 0.1 mole of H2SO4. They are asking for the number of atoms and what is given, number of moles is given, and our substance is H2SO4. So we write 1 mole of H2SO4 is equal to 6.023 into 10 raised to power 23 number of. Now since H2SO4 is a compound, so the smallest particle of a compound is molecules. So we'll write number of molecules, right? 1 mole of H2SO4 is equal to Avogadro number of molecules. Now 0.1 mole of H2SO4 is equal to, now you can see here this is a very simple calculation. 1 to 0.1 means you are dividing by 10. So this side also you divide it by 10, and if you divide this by 10 it will be 10 raised to power 22. So I'll write 0.1 mole of H2SO4 is equal to 6.023 into 10 raised to power 22 number of molecules. So you understand that in 0.1 mole there are this many number of H2SO4 molecules, but they are asking how many number of hydrogen atoms are present. Now in 1 molecule of H2SO4, 1 molecule of H2SO4 contains how many hydrogen atoms? There are 2 hydrogen atoms. So 2 hydrogen atoms. 1 molecule of H2SO4 contains 2 hydrogen atoms. Therefore, these many molecules which is present in 0.1 mole contains how many hydrogen atoms? So we will get the answer that what 0.1 mole of H2SO4 contains how many hydrogen atoms. So basically we first found out 0.1 mole of H2SO4 contains how many molecules of H2SO4. Now since one molecule contains 2 hydrogen atoms, therefore so many molecules will contain how many hydrogen atoms. Now let us do. So 6.023 into 10 raised to power 22 molecules of H2SO4 contains 2 into this, 2 into 6.023 into 10 raised to power 22 molecules, atoms. hydrogen atoms. Okay, so now you can multiply these two and write down the answer, or you can keep the answer this way also. Both of them will work. Okay, so even this is acceptable. So yeah, this is a sum. Let's proceed to question number 10. Find the number of molecules in 1 kg of calcium chloride. So we need to find out the number of molecules which is related to the Avogadro's number, and 1 kg which is given, which is related to the molecular weight. So we are going to write molecular weight of the substance is CaCl2. So CaCl2 is equal to Avogadro number of molecules 6.023 into 10 raised to power 23 number of molecules. So molecular weight of CaCl2 would be is equal to Avogadro's numbers of molecules. So now let us find out what is the molecular weight of CaCl2. Ca is 40 and Cl, chlorine is 35.5. There are 2 chlorines, so 2 into 35.5, that is 40 plus this is coming 71. So that's 111 gram. So 111 gram of CaCl2 is equal to 6.023 into 10 raised to power 23 number of molecules. This we got, right? So 1 kg. Now remember that in chemistry, weight is always, by default, weight is always given in gram. Remember. So if this is 1 kg, molecular weight is given in gram, so we have to convert it into gram. So 1 kg, that is equal to 1000 gram of CaCl2 is equal to how many molecules? Let it be x. Now cross multiply, 111x is equal to Avogadro number into 1000, right? So x is equal to 6.023 into 10 raised to power 23 into 1000 divided by 111. So when you calculate this, you get the number of molecules. Now here you can do little approximation if you want. You can put this as 6 instead of putting the whole thing 0.023, and instead of 111 you can put it as 110 or maybe 100 also, so that it gets cancelled and you get the calculation. Otherwise you can just divide and get the answer. So this was the 10th sum. Now let us proceed to the question number 11. So in question number 11 it is asked that how many grams of aluminium are present in 0.2 mole of it. So they are asking for how many grams. That means this is related to the atomic weight or molecular weight of the substance. Since it is aluminium, which is an element, so it is related to atomic weight of the substance, and it's given 0.2 mole, so we will take 1 mole of a substance. So now we are going to write 1 mole of aluminium is equal to atomic weight of aluminium. So 1 mole of aluminium is equal to, the atomic weight of aluminium is 27 gram, so it's 27 gram. Therefore 0.2 mole is equal to how many gram? Cross multiply, x is equal to 27 into 0.2, that is 5.4 gram. So in 0.2 mole of aluminium, how many grams are there? 5.4 grams are there. In question number 12, we have similar type of sums. How many grams of HCl are present in 0.1 mole of it? Again, they are asking for how many grams, that is related to molecular weight or atomic weight, and they have given the number of moles. Second sub question is how many grams of H2O are present in 0.2 mole of it, or how many grams of CO2 are present in 0.1 mole of it. All the three questions are similar type. We did same type of question in the previous sum, that is in the 11th one. So either you can do all these three sums by using the method what we have used in the 11th question, or you can directly use one formula. We have one formula, that is number of moles, which is denoted by N, is equal to weight given in grams divided by molar mass. Molar mass or molecular weight or atomic weight, depending on the substance. Molar mass or atomic weight, whatever you say. So number of moles is N, denoted by N.
weight which is given in gram denoted by W, or sometimes it is denoted by small m also, and molar mass is normally denoted by capital M. So you remember this formula, or otherwise you can use the previous question, 11th question, the same way we can do this sum also. So now they are asking how many grams of HCl are present. So they are asking for this, how many grams, that means they are asking for W. In 0.1 mole, that is 0.1 mole N is given, and since it is HCl, the molar mass of HCl is 36.5. So you can just put it in the formula, and therefore W will be is equal to 36.5 into 0.1, which is 3.65 gram. So this is the answer for the first question. Same thing, if you use the same formula for the second question, they are asking how many grams of H2O are present in 0.2 mole of it. So now the number of mole is given 0.2, and how many grams of H2O, so that is W they are asking for, and H2O, the molecular weight of H2O is 18. So W will be 18 into 0.2, so that will give you 3.6 grams. So here the value of W is 3.6 grams. Same thing in the third question, here we are going to see how many grams of CO2 are present in 0.1 mole of it. Now again the number of moles is 0.1, W they are asking, and the molecular mass of carbon dioxide is 44. So W is equal to 44 into 0.1, which is going to give you 4.4 gram. So this way we can do this type of questions where the molecular mass is asked and the number of moles is given, or vice versa. The number of moles is asked and molecular weight is given. We can directly use this formula. Let us proceed to the next question, that is question number 13. The mass of 5.6 liters of a certain gas at STP is 12 gram. So here, sorry, 5.6 liters, that is the volume is given, and the mass is 12 gram, that is this is related to the molecular weight. Okay, what is the relative molar mass of the gas? They are asking for the relative molar mass. Now again, the relative molar mass or the molar mass or the molecular weight is the same thing. So we know that we have the relationship. First of all, we need to understand which two things we are going to take out from those four relationships. One is liter, which is related to 22.4 liters at STP, and one is 12 gram, which is related to the molecular weight of the substance. So here we are going to write molecular weight of the substance is equal to 22.4 liters at STP. So now we do not know what is the molecular weight, so let it be X. X is equal to 22.4 liters, right? So, and 5.6 liters, the weight of this is 12 gram. So now cross multiply. When you cross multiply, we get 5.6x is equal to 22.4 into 12. Therefore, x is equal to 22.4 into 12 divided by 5.6. So now there is a point one digit ahead. Here also one digit ahead. So we can cancel it out. 224 into 12 divided by 56. This go by 4 stable, 4, 3. 4, 1, 4, 4. This go by 2 stable, 2, 7, 2, 1, 1, 2, and 7, 1, 7, 7, 6. So this is 48 gram. That means if X is 48, that means that 48 grams, the volume of 48 grams of the gas is 22.4 liters at STP. That means this is the molecular weight of the substance. So the relative molecular mass of the gas is the RMM, relative molecular mass of the gas is 48 gram. Now in question number 14 they say calculate the volume occupied at STP by 2 moles of SO2. So again the volume occupied means it is related to 22.4 liters at STP. And 2 moles means it is related to the number of moles of the substance. So we are going to write here 1 mole of, now our substance is SO2. So 1 mole of SO2 is equal to 22.4 liters at STP. This is the reference we have. 1 mole of any substance is equal to 22.4 liters at STP. Therefore 2 moles will be is equal to how much volume? Cross multiplies, it is X is equal to 2 into 22.4 and the answer will be 44.8 liters. So the volume occupied by 2 moles of SO2 is at STP is 44.8 liters. So we have reached to question number 15, and that is the last question for today's video. Question number 15 says calculate the number of moles of CH4 in 0.80 gram of CH4. So they are asking for the number of moles. So we are going to write 1 mole of CH4 is equal to 0.80 gram, which will be related to the molecular weight. So that is equal to molecular weight of CH4. So now in the next line, we are going to calculate the molecular weight. So 1 mole of CH4 is equal to, molecular weight of CH4 is 12 plus 4, that is 16 gram. Therefore, 0.80 gram is equal to how many moles? So cross multiply 16 into x is equal to 0.80 into 1, that's 0.80. So x is equal to 0.80 divided by 16. Now we will remove this point, so we are going to write 80 upon 100 into 16. Now 16 into 5 will give you this. So 16 5s are 80. So we are getting 5 upon 100, that is 0.05 moles. So how many moles are there in 0.80 gram of CH4? 0.05 moles are there in 0.80 gram of CH4. So this way we have to do the questions or numericals from Avogadro's number. So basic thing is we need to remember the 4 relationship which I have given you in the very beginning of this lecture. That is 1 mole of any substance is equal to molecular weight of that substance is equal to 22.4 liters at STP is equal to 6.023 into 10 to the power 23 number of particles. Now whatever is given in the question and whatever is asked, according to that we are going to take out the 2 things from the reference and then we are going to calculate the problem. Okay, so this way we have to do Avogadro's number. So if you want more questions to be solved, I think I will get another video. I'll come up with another video based on Avogadro's number, and then I will move on to the next topic, that is empirical molecular formula and percentage composition. Thank you so much. The next video will be mostly on Avogadro's number only. A few more sums we are going to solve in the next video. Okay, thank you so much. Stay tuned.